Hey guys, welcome back. This is going to be 6B. We're looking at solving systems of linear equations with 3 variables and 3 different equations. Now, the process we are going to develop in this lesson is a process called Gaussian elimination. We can actually do this with systems of equations with more than just 3 variables or more than 3 equations as well. Before we actually jump into how to do this with matrices, though, I wanted to try to ground it to something that's already a familiar skill, which we have, and we've kind of carried through since year 10. So I'm going to look at solving this with my current skill set of using the elimination method with solving simultaneous equations. So I've got my 3 equations here. You can see the textbook has already numbered them 1, 2, 3 for myself. With my elimination method, what I want to look at is the coefficients of my different variables. You notice in equation 2, there's actually no x variable. If I keep highlighting, I've got kind of 1 lot of y here, 3 lots of y. There's no y's in equation 3. And in front of my z's here, I've got 3 z variables. Now, this question has kind of been tailor-made to make the elimination process a little bit easier and a little bit more straightforward. You can notice we're already missing a few variables from my other equations. However, the general idea here, and the way we do this with matrices, will apply to even the most complex systems of equations. So if I'm using my elimination method, I want to look at my coefficients, and where my coefficients are the same, I either want to add or subtract depending on what sign's out the front. You can see here with my z's in equation 1 and equation 3, the coefficients are both 1, so I can simply go ahead and eliminate those 2 variables. Both those 2 values are positive. If the values are the same, we want to subtract. So I'm going to take equation 3. I'm going to subtract that from equation 1. Now I'm going to write these equations out above each other, and where I have a y, I'm just going to put plus 0 lots of y just to make it consistent. That's going to be plus z minus, that's going to be 2x plus y plus z is equal to minus 1. Now, I'm going to be subtracting these equations. 6 minus 2 is going to give me 4 lots of x. This is simply going to give me negative y, and this is going to give me my z's are going to become plus 0, and 8 minus minus 1 is going to equal 9. So I've now created a new equation with just 2 variables, and now I've kind of converted this to a more classic simultaneous equations type of question. I'm going to call this equation 4. So I'm just going to rewrite this equation a little bit neater. That's 4x minus y equals 9. That is what I will call equation 4. So let's just move that little bubble down here. So that's equation 4. Now, I want to generate another equation, which is just 4x minus y equals 9, and then I can do my normal simultaneous equations method to solve. So if I have a look here, again, I want to make one of my coefficients the same. I've already eliminated my z for equation 4. So if I do 4 multiplied by 3 minus equation 2. So if I go ahead and do that, that's going to become 24 lots of x. So that's 24 lots of x plus 0 lots of y plus 4 lots of z is equal to, times my n number here by 4. 4 times 8 is going to give 32. So I've times my entire equation 3 by 4. You can see I've kept that consistent all the way across the very end. And now I'm going to subtract that from equation 2. Equation 2 is 0 lots of x plus 3 lots of y plus 4 lots of z is equal to minus 7. And again, now I'm going to go ahead. I'm going to subtract those 2 equations. That is just simply going to give 24 lots of x minus 3 lots of y. That's also going to become plus 0. And if I do 32 minus 7, that's all going to equal 39. So I've got 24x minus 3y equals 39. This is going to become equation 5. So it's slightly more complex than when I do elimination method with 2 equations, just simply because I have more equations I need to process. However, the ideas are still exactly the same. So let's give myself a bit more space. So I've got these 2 equations here. I've got 4x minus y is equal to 9. I've got 24x minus 3y is equal to 39. Now, this question does just look like a relatively more familiar elimination method question. I'm now going to times equation 4 by 3. So I times equation 4 by the number 3. And I might keep my bigger number at the front. That's going to be equation 5 minus 3 times equation 4. So now if I scale this equation here by a factor of 3, you can see I'm going to have minus 3y and minus 3y. They're going to eliminate. So if I do 5 minus 3 times equation 4, that is going to become 24x minus 3y is equal to 39. 12x minus 3y is equal to 27. So once I've got these two equations here, again, I'm going to do my subtraction. That's going to give me 12x is equal to 12. So x is going to equal 1. So x is going to equal 1. Now I can start substituting back in. So therefore, sub x equals 1 into let's do equation 4. So we sub x equals 1 into equation 4. Equation 4 is this equation here. So it's going to become 4 minus y equals 9. So that's going to become 4 times 1 minus y is equal to 9. So y is going to equal -5. Now I've just got one more thing to solve. That is going to be z. I can sub x equals 1, y equals -5 into really any of my equations that have a z in it to get this answer. I'm just going to choose equation 3. So I'm going to sub x equals 1 into 3. That's going to become 6 times 1 plus z is equal to 8. So z is equal to 2. So therefore, x equals 1, y equals -5, and z is equal to 2. That's my solution to those three equations using elimination method. So that is my first example using elimination method. And we can see it's quite a long process. There's a lot of steps and it can be quite tedious. So there's a more efficient way to go about it. And that is where our Gaussian or our Gaussian elimination comes in. So it has the word elimination in it because it works on the elimination method. So it's a very similar process, but instead we're going to look at it as a coefficient matrix, try to make our coefficients equal 0.